Today, we'll still be interpreting graphs, but we'll be speaking about two separate or different concepts than Tuesday. Okay? Later on, we will have a little bit of a reminder of Tuesday's lesson when we are answering questions. So I hope you guys have the notes from Tuesday ready to go. All right. Now, we already spoke about the types of line graphs that we had. We spoke about it briefly on Tuesday, and today we're going to learn the differences and what it is called, or what those graphs are called. Now, when we have a line graph that is constructed out of discrete data, which is the first type of data we're going to speak about, this data is the type that can only be counted, which means it is only whole numbers. Now, who remembers what whole numbers are? We did it all the way in the beginning of the year. Or who just knows what whole numbers are? What am I referring to when I speak about whole numbers? Does anyone remember? It is counting numbers including zeros. So 0, 1, 2, blah, 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 all the way to positive infinity, okay? This does not include decimals or fractions or negative numbers, okay? So everything here would be a whole number or a positive whole number. This type of graph will be indicated by dotted lines that are not joined by a line. So when you see a graph that is joined by these lines, that would be a discrete data graph. Okay. And then the other type that we have is called continuous data, and this is data that can be measured. All right, so this is involving all real numbers. That means including negative numbers and including fractions and decimals. Okay, so this graph will be indicated by a solid line or curve. All right, so let's go and see what I'm talking about here. I just wanted to fix my solid line. There we go. Let's go through these examples based on the definitions that we have just spoken about. So my first type of graph speaks about the time it takes to get to school. Firstly, is time measured or counted? Let's speak about this. Would you say time is a measured type of data or a counted type of data? What do you guys say, guys? Is it discrete or is it continuous? Okay, I have an answer from Singyani. What do we all say? And Mavis? Counted, measured. So time isn't actually measured, right? Think of a stopwatch, guys. If I am competing with you and we are swimming, all right, and we want to know who's in first place and who's in second place, and the first person finishes it in 1,5 minutes and the second one in 1,27 minutes, which one do you think is going to win here? Which one do you think is going to win between these two guys if we are swimming in a race? And the 1,27, because they took the least time. Okay, they took the least time. So that means that time is in fact a measured data, guys. There can be decimals in time. If I say to you 0,5 hours, what does that mean? What does 0,5 hours mean? It means it is 30 minutes. Do you see that it's possibly, yes, half an hour or 30 minutes? It makes sense. It is a decimal, but it makes sense. So that means that time is measured. Okay. You can have decimals in time. And when you look at this graph, it is represented by a solid line. So does that mean we have a discrete or a continuous type of graph here? Now that we have established that time is measured, is it discrete or would you say it's continuous? What do we say, guys? It is in fact continuous. So this is a continuous graph. Okay, so our first clue is that we have a solid graph, right? And the second clue is my type of data, which is minutes. You can have 2,5 minutes. It's possible. You can have 2,743 minutes. Okay, let's look at the second example. Here's a table of data that shows the number of flowers in a field. Number of each flower. Is this measured or counted? Is the number of flowers in a field measured or counted? It's counted, okay? Because if I said to you, you have 12,2 daisies, does that make sense to anyone? No, it's in fact very confusing. You don't know what 12,2, what is comma 2 of a flower? I don't know what it is, okay? So this is counted data. So that makes this, is it continuous or is this discrete? If we are counting the number of flowers in a field, would you say that is continuous or that is discrete? Yes, it is. This is discrete data. Discrete, this way. Okay, that discrete means something else. It means it is hidden. All right. The next one is the temperature throughout the day. So this person started checking temperature from 11 a.m. to 4 p.m. So is this measured or is this counted data? Nice, we're getting somewhere. This is measured. Firstly, we have a solid graph. And the reason it is a solid graph, guys, let me tell you something why this would be a solid graph. There is data everywhere on this graph. Listen, this is what I mean by that, okay? So at 11 a.m., let's say we would say this is maybe 12 degrees Celsius, right? And then at 12 all the way up there, which is maybe 16 or 17 degrees Celsius. But no matter what time you would check this temperature, you could be able to get a reading. So let's go to 11:30 over there. This temperature didn't just jump from 12 to 17. At some point, it was 12,5 degrees Celsius. At some point, it was 13. Then it was 13,2. Then it was gradually increasing. Okay, so everywhere on this graph, there is a data point. You might be checking the specific hours, right? But anytime during this day, you could have gotten a reading over there. Like in random places, you could have gotten a reading for the temperature because it does not just change from 12 and become 20 degrees Celsius. Think about when you're out on a day. It might be a little bit cold in the morning, but it slowly gets warmer and warmer. It doesn't just jump from maybe 10 degrees Celsius and now it's 31 degrees Celsius outside out of nowhere. Okay, so does that make this discrete or continuous? We have established that we are measuring the temperature. So does that mean it's discrete or is continuous? Nice. It is continuous. Nice, guys. We're getting somewhere. The next one, a table that shows the number of each different type of animal on a farm. Different type of animal. Are we counting the animals or are we measuring the animals? Are we counting them? If I say I have a farm and I want to know what I have on the farm and how many I have, will I be going out and counting those animals or will I be going out and measuring them? That is true, guys. Beautiful. You'll be counting them, right? If you want to check how many dogs you have, you're literally going to go 1, 2, 3, 4. There is no time where you would say 1,5. Okay. So then we have established that this is counting. So is it discrete or is it continuous? Nice. This is discrete data. Beautiful, guys. Okay, let's move on. This graph, we saw it on Tuesday as well, but this time I want to show you. Remember I asked you guys why you think this is a dotted line? And now we know why it would be a dotted line. And why is that, guys? The number of cars that were sold in 2019. Why would we have a dotted line? What do you guys think? It is dotted because the type of data we have is what? Is it discrete or continuous? Anyone? If I want to know the number of cars I sold, it's discrete. Nice, guys. You can't say you sold 0.2 of a car, right? If it is a wheel that you sold, you say I sold a wheel or a tire or the rims or a steering wheel. You don't say I sold 2.5 of a car. Do you guys get it? Right, now before we move on, can we have a thumbs up, thumbs down on the difference between discrete and continuous data? It's very important that you guys understand those two, okay? And it's important to understand when you are drawing a graph as well. It's not just important for when you are interpreting graphs. I've seen it a lot of times in physics and life sciences because I teach those. When I ask people to draw a graph and we have the wrong graph. Like it's a line graph, but you either draw a dotted one when you're supposed to draw a solid one, or you draw a solid one when you're supposed to draw a dotted one. So you need to know. Yes, SPA. And EMS as well. You better know these two types, okay? Now let's talk about minimum and maximum of graphs. Okay, I want to talk first about minimum and maximum of anything. All right? It's okay, Butlale, welcome. All right, so I want to talk in general. What does minimum mean? What does minimum mean in general? Forget about graphs. Minimum means the least. So it's the lowest possible value. And then what does maximum mean then? If it means the least, nice. Maximum means the most, which is the highest possible value. Possible value. Great. Now we have graphs that only have a minimum or only have a maximum, but we also have graphs that have both. Okay, now let's talk about this graph that I'm looking at here. Firstly, I'm going to fix it and draw these. What do those arrows mean that I'm adding there? We spoke about this last term when we spoke about graphs. Why am I putting arrows at the end of this graph? What do those arrows? It means the graph keeps going. Nice, Mavis. Infinity, it keeps going. This graph does not stop at this point at -5. My axis stops here. All right, my axes stop here. But then this graph keeps going. If I could draw it forever, I would. So you're just indicating that this graph does not stop here. It keeps going forever and ever and ever and ever. So in a graph such as this one that we're looking at here, right, we have a turning point, which is over there. Okay, is that point a minimum of this graph or a maximum of this graph? Now, one piece of information I have to give you is we always look at minimum and maximum as it relates to the y-axis. Is it a minimum or is it a maximum? Look at your y values. Okay, I'm gonna write here. This maximum, or this, okay, well, I just told you it's a maximum. This turning point is at 1,0, right? So if that's 2, then that's 1. What is the point here where the axes cross? What is the point over there? Or what is the value of y where the axes cross? It's 0. That's true. And then here it is -1, -2, and then -3. Now let's look at that turning point, which is 1. Okay, are the values of y getting greater or are they getting smaller? Would you say the value of y are getting bigger or they're getting smaller? I started off at 1 and then I go 0, -1, -2, -3, -4, -5. They're getting smaller, right? So is 1 the biggest possible value or is it the smallest possible value? Is that 1 comma 0 the highest possible value or is it the lowest possible value of this specific graph that we are looking at here? It is the highest because everything after that just keeps getting smaller. So if it is the highest possible value, does this graph have a minimum or does it have a maximum? Spa and Leachilwe, do you understand what I mean? When I say it is the highest possible value, it is indeed a maximum. Don't be sorry, you just need to learn. We're here to learn, right? So we need to understand that all the other values of this graph will be less than 1. That means that 1 is your highest possible value that you will ever get in this graph. That means it has to be your maximum. Okay, let's look at what a minimum would look like. This is a minimum. Okay, there's my turning point over there. My turning point is at -1. Can barely see that. My turning point is at -1. Okay, and then this graph goes from -1 to 0, and then 1, 2, 3, 4, 5. Is this graph getting bigger and bigger in value or less and less in value? Remember, we're looking at the y-axis. It's getting bigger and bigger. So was -1 the lowest possible value you could have gotten, or was it the highest possible value that you could have gotten? It was the lowest possible value. So does it have a minimum or a maximum? Nice. That means that -1 would be your minimum. Nice, guys. Beautiful. Okay, are we getting this? Is it getting into our minds? Now let's look at this example. Okay, we have a table here. I just want to clarify that we're looking at the table. Okay, we have a table and it has time and height. Now, just looking at the table, me, myself, I can tell that this table is from throwing an object in the air. And this is why I say so. This is you. Okay? You're feeling blue. I'm kidding. I just felt like, yeah. You're holding a ball, right? And you're going to throw it up. What's going to eventually happen with that ball, guys? What eventually happens with that ball that you threw up into the sky? Anyone? Don't try to overthink it. Just tell me what's going to happen once you throw that ball up. It has to come back down. Okay, so you're going to throw it and it's going to keep going, going, going. But eventually it's going to reach its maximum height and then it's going to start coming back down. Okay, depending on how hard you threw it. So this 1 meter means the distance between the ball and the ground, because you're holding it. It's not on the floor, right? You're holding it. So the distance between that ball and the ground would be the first value, which is 1 meter. Okay? After a while, after you've thrown it, let's say it's 9,75 meters, and then it's 16 meters, and then it's 19,75 meters, and then at the maximum point, it's going to be 21. All right. After the highest point your ball can reach, it starts coming back down. So then it's back at 19,75. Then it's back down to 16. Then it's back down to 9,75. And let's say you've moved and now you're standing here or your friend is there and they catch it again. And the ball once again will be 1 meter above the ground. Okay. So everyone looking to do physics next year, this is what you're going to be doing. So in such a scenario or case, do you agree that my ball has both a minimum and a maximum? What is my minimum height above the ground? My minimum height above ground. Minimum. It's here. Nice, it's 1 meters. That's the closest that my ball is above the ground. It's not on the ground. It is 1 meter above because I am holding it, right? And then what is my maximum height above the ground? That would be 21 meters. Okay. Do we understand the differences between minimum, maximum of a graph? Can I have a thumbs up or a thumbs down? Nice. Yeah, the thumbs ups all exploded, so I can't tell who didn't do it and who did. They just keep exploding. Okay, now we're going to have a bunch of graphs. That's what I mean when I say you need to recall your memory from Tuesday, okay? Because firstly, for all these graphs, I want to say if they are continuous or discrete, and I want reasons, okay? You can't just guess, okay? Next, we're going to say if it's linear or non-linear. Recalling any memory here. Then you have to say if it is an increasing, decreasing, or constant graph. And then you guys have to tell me the maximum or minimum values for all of these graphs. This is our first one that is on the screen. There. Number 1. Is this graph? We have no idea what this graph represents, but you can answer all these questions just by looking at it. Okay, so if we look at the first graph that we have here, is it discrete or is it continuous? Nice. Spy has an answer for us already. Why? What is my reason? What is my reasoning? Spy says it's continuous, and I agree. It is continuous. Nice, Mavis, because it is a solid line. Number 2, do we have a linear or a non-linear graph? Now we're going back to Tuesday's lesson. Ha, Sengyani, I love it. This is non-linear because it is curved. We do not have a straight line here, so it is non-linear. Number 3, do we have an increasing, a decreasing, or a constant graph? Nice. It is decreasing, guys. The first value of this graph is 70, and we end up at 20. The points are slowly getting smaller and smaller and smaller and smaller. So this is definitely a decreasing graph. And finally, what are the minimum and maximum values? What is the minimum? Nice. The minimum is 20. Remember, we are reading values off of the vertical axis. So you can't say that the minimum is 5 because that's the wrong axis. Okay. So 20 is correct, which means my maximum is nice 70. Beautiful. Another thing, I see none of you made this mistake, but I have seen it very often, well, often enough. When we are talking about minimum or maximum, we're talking about the minimum maximum of the graph, not of the axis. Okay, so you can't tell me that the minimum of this is 10 because there is no point in 10. Okay, the graph doesn't even reach 10. So remember, we're looking at the graph when we speak about minimum and maximum. We're not looking at the axis. Okay, great. Let's move on to the next one. First question, continuous, discrete. Do we have a continuous or a discrete graph? Okay, maybe it says continuous. Why is that? Nicely, Achille. This is a solid graph. It's a solid line. Second, is it linear or non-linear? Linear or non-linear? Great. It is linear because it is a straight line. Okay. Third one is it an increasing or decreasing graph? Increasing or decreasing graph? It's here. I have increasing, increasing. Where does this graph start? Let's check where this graph starts. At a point of 60 and ends up at that point. So is it decreasing or increasing? This is actually a decreasing graph. Your points get smaller and smaller and smaller as you go. If you look here. Okay, remember we're reading them from the vertical axis, not the horizontal one. And then the last one, what is my minimum and my maximum for this graph? Nice, for one of them. My maximum is 60. But what is the minimum for this graph, guys? We are reading off the vertical axis. Nice. The minimum is 0. It goes all the way back down, which makes it 0. Nice. Makes sense? Okay. We have a third one. First question, continuous, discrete. Continuous or discrete? What do we think, guys? This is discrete, and what is your reason? Le'achilwe, what can you see on your screen? Because it is dotted. Nice. Second question, do we have linear or non-linear? Look carefully. Is this linear or is it non-linear? It is non-linear, guys, and if you can't see it, I'm going to prove it by putting a line in between the first and last points. Look where all the other dots are. Are they all in a straight line? This is non-linear because they are all not in a straight line. So this is actually curved. Okay. Number 3. Is it an increasing or decreasing? All right, Leachile. Is it increasing or decreasing? This is still a decreasing graph. And number 4, what is my minimum and maximum? Once again, it starts all the way on the axis, which means my minimum has to be 0. And my maximum is all the way up there. And if you read that off, that would be a 80. Beautiful. Okay. This is indeed a graph. It's over here in case you can't see it. Okay, firstly, is it discrete or is it continuous? Do we have discrete or do we have continuous? Why do you say that, Mavis? Continuous. Why do we say it's continuous? Nice, because it is a solid line. Great. Of course, I'm going to forget what's next. Linear or non-linear? Is this a linear or a non-linear graph? That is true. It's linear because it is a straight line. It doesn't bend, it doesn't change direction, it doesn't curve. So it is linear because we have a straight line. 3, is it an increasing, decreasing? Or constant. Saying it was already like it's a constant graph before I even asked. It is a constant graph because it is straight. It's horizontal. Okay, so if a graph is horizontal, which is that way, or vertical, which is that way, that will be a constant graph. Okay, and now let's look what happens when you have a constant graph. Isn't this interesting? What is my minimum for this graph? Nice, Singani. Both of them are 40, which is true for a constant graph. If you say you have a constant graph and you have different minimums and maximums, then either you are wrong with the minimum and maximum or you do not have a constant graph. Okay, now this one is a little bit interesting. Firstly, continuous or discrete. Ooh. Continuous or discrete. This is still continuous. I'm going to stop writing the reasons now. Do we have linear or non-linear? Nice, Singani. This is non-linear. Great. Third one, is it increasing or decreasing? Nice. Mavis, this is increasing. It looks strange, but it is increasing. And finally, what is my minimum and what is my maximum? Minimum is 10 because it starts at 10. It does not start at 0. And my maximum is 60. Beautiful. Great. I think we can now move on to this one. Before I move on, can we have a thumbs up, thumbs down on all the others that we have done? Great. Now, let's look at how we would realistically get these questions in a test paper. Okay. So obviously you will probably get a graph like this, and they will ask you a bunch of questions like so. So let's practice how we would answer these questions. So this graph represents the number of rhinos that were poached between basically 2000 until 2014. All right. So let's see. First one says, how many rhinos were poached in 2010? How many rhinos in 2010? So we're going to go to the year 2010, and then obviously you go up, up, up until you touch the graph, and that would be 333 rhinos. What is the minimum number of rhinos poached per year starting from 2009? Starting from here, what is the minimum number of rhinos that were poached? It's the one in 2009, 122. Everything else after that is greater than it, right? So it is actually 122 rhinos, which were poached in 2009. What is the maximum number of rhinos poached from 2009 to 2013? Indeed, Senyani, this is the maximum number. Can you see how hectically it's increasing, guys? That's why these are endangered. Okay. In which year did poachers slaughter 668 rhinos? I almost said lions because my brain is mush at this point. There we go. And the year is 2012. Great. So this one we're not going to answer because there was a case study and we don't know what the scenario is. We don't know what happened between 2008 to 2009 that made poaching of rhinos decrease, okay? But let's move on. It says, is this trend linear or non-linear? Non-linear, and my reason is what? Why are we saying non-linear? It isn't curved, but it changes direction. The line is not straight. Okay. And then the last one, is this discrete or continuous? It is discrete because of the dotted line. Or you can say, what is the other reason that you can say, guys? Look at the what we are measuring here. Number of rhinos. Okay, can we have 5 of a rhino? Is that possible? No. So you can either say it's a dotted line or it is counted data. Okay. I haven't been giving you guys a chance to screenshot in a while. So now you can screenshot. All right, now we move on. The following graph represents the distance of an object from O. That's not a 0, that's a O. The vertical axis represents the distance in meters. They wrote it in for us. The horizontal axis represents the time. Now let's see. How far away was the object from O at 7 o'clock? If you look at where the graph starts, which is 7 o'clock, how far was the object? Nice. It was 50 meters away, okay? If it was 0, then it would start over there, which it doesn't. So this is actually 50 meters. Great. How far away was the object at 8 o'clock? 8 o'clock is over here. And if you look up there, that looks like it's in line with 100 meters. Great. How far did the object move in the first hour? So from 7 to 8, how far did the object move? Let's hear. How far did the object move in the first hour? Yes, Bukhali, it is indeed 50 meters because it was already 50 meters away. Okay, so if it was 50 meters away and it moved to 100 meters away, it only moved 50 meters. Okay, how far was the object at 10:30? So if this is 10 and that's 11, 10:30 is right in the middle. Let's go up, 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 there. That is indeed 100 meters. Okay, explain what is happening between A and B. We saw this again on Tuesday. What's happening here? What does flat line mean? It is constant, but what is happening? When they say explain, I want you to tell them what is happening. What stayed the same? These questions are a little bit more tricky. You need to tell us exactly what it means. If this graph is talking about an object that is moving, then what is happening between A and B? The distance did stay the same, but what does it mean, guys? It's an interpretation of it. It means it did not move. It means the object did not move. You need to interpret and tell us exactly what it means, or we're not going to give you the marks. So you need to say it means the object did not move. Okay, that's what interpretation means. You can't tell me something I can see from the graph. Okay, I can tell the distance is the same, but what does it mean? It means the object didn't move. Okay. During which times was the distance increasing? Okay, how do we know when a graph is increasing? During which times was it increasing? Let's look at the graph. What do we think? It's here, guys. When was this graph increasing? Which times? 7 to 9, that is true. If you look at here, from 7 to 9, that is indeed increasing. Is that the only time when this was increasing? And 10:30 to 11. Nice, guys. Great. During which times was the distance decreasing? When was the distance decreasing? Let me highlight this one as well. 11. Where's 11? 11 to 12. That is true. So there. And 10 to 10:30. Who wrote that? Sinyani. There. So 10 to 10:30, the distance was decreasing. And as well at 11 to 12. Just pretend my 0 looks fine. Okay, what is the maximum distance that this object reached from O? What is the maximum distance? Nice. That would be 200 meters. At what time will the distance from O be 0? At what time will the distance of this object from O be 0? That is true. When it's back on the axis, the only time it touches this axis is at 12 o'clock. So that would be at 12. What is the total distance moved by the object? Not from O. It just says the total distance it moved from 7 to 12. How do you guys think we will do this? The total distance it moved. Nice. We have to add. So when it was increasing, how much did this object move? So from the beginning to A, how many meters did this object move in total? Look carefully. The beginning was at 50 meters, guys. So it went from 50 to 150. So it only moved 100 meters. Great. And then it stood still. So it moved 0 meters here. Okay. But then it moved again. It was at 150 meters and it moved to 100 meters. So how much did it move? How much did it move? It moved 50 meters. Okay. Great. And then it moved again from 100 to 200 meters. So how much did it move there? It moved 100 meters. And then finally it moved from 200 back to 0. So how much did it move there? It moved 200 meters. Now let's add these, guys. I have 100 plus 0 plus 50 plus 100 again plus 200. So that means in total, this thing moved a distance of 450 meters. Great, guys. Whoever's doing physics next year, you're going to learn displacement. So the distance is 450 meters, but the displacement is only 50 meters because it started 50 meters away in the first place and then came back. So all of this, when you're talking about displacement, will be irrelevant. It will be from starting point to finish point, but it's fine. Okay. All right. Let's see. We're not going to answer all of these, but just a few of them. So this is the number of cells in a test tube. Okay. in millions over hours. Okay. How many cells were there in the test tube initially? So at the beginning, in the beginning, how many cells were there in the test tube? Look at your axis labels and look at what you are counting in. Nice. Mavis didn't fall for the trap. The rest of you did. It says in millions. So if you say 2, you are wrong. There were initially 2 million cells in the test tube. Great. How many cells are in the test tube after 1 hour? It is still 2 million. All right. Explain what is happening between A and B. Once again, we have a flat line. So what is happening there? It is constant, yes, but what does it mean? There were no divisions, right? Nothing happens. After how many hours are there 7 million cells in the test tube? So 7 is all the way up here. And if I go close to my graph, how many hours does it take to get there? That would be 3 hours. Nice. Okay. Explain what's happening between B and C, but I want you guys to explain it in terms of graphs. There we go. It is an increasing graph. So it is increasing. And in terms of graphs, tells me between C and D, what is it? It was an increasing graph. Now it is a between C and D. Now it is a constant. After how many hours are there 4 million cells? 4 is over here. 2 hours. Is 2 hours the only one? If I go to the, see there. We actually should have had, no, this is above the line, never mind. 2 hours, but also if you keep going, guys, there's also, it's 9 hours. 2 and 9 hours. Between D and E, what's happening with this graph? It is decreasing. Is this continuous or discrete? Discrete, and it says explain. Discrete. Dotted line, and we are counting, okay? The number of cells. There's either 1 or 2. There can't be 1.5 cells. Great, and then after 1.5 hours, can we read off? That will be very difficult. It's over there though. There. After 1.5 hours, that will be about there. How many cells do I have there? 3 million. 3 million, not just 3. Okay. Okay, guys, I think we can call it a day.